Okay, then first, hello everybody. Thank you for attending our talk. In our talk, we speak about hackers, about some different kind of attack, and all of them will be focused on software development processes, workflows, and so on. We'll try to show different kind of attacks and sometimes different kind of defenses, right? Okay, a bit of spam about us. I think that nothing more to add, or do you want to add something, Cesar?
Yes, I work on BBVA Next Technologies. It's a company of technology company from a Spanish bank, and I work for a long time with data, and now I'm focused more on security over data and security itself. And I must say that it's an exciting work nowadays. I'm learning a lot.
Nice. I only will add that I'm currently working as a security research API consultant for 42 Crunch, a company focused on security in the APIs. And that's it. You can get in touch with our Twitter, with LinkedIn. You can, is this in this slide? Or, okay, done. First, a very big disclaimer about our talk, because we'll see some real attacks, and that we are showing are our own opinions, are expressed, are not by a company that are employers to us, right? It's legal reasons, right?
Okay, let's start with core concepts. So let's take a 10,000 feet look at the modern software pipelines. Next. Okay, first of all, what continuous integration is? Continuous integration tools born from groups of developers while they work on the same code base and they can talk each other. First, we work in order to keep correctness, even after several code merges. Then test drive development comes to town. Things start to be more interesting. Now we can be sure that our code is consistent and works on the most important parts. Also, you have there the Wikipedia definition that it's a pretty boring thing. Okay, next. Okay, what continuous deployment is? In fact, developers' confidence was so high that they start to automate push to production machines without human intervention or manual revision. Testing techniques become the safety net of developers. Now we feel safe about our code. Every commit now has high probabilities to trigger a new deploy to production, and without the old struggle between developers and operations, new exciting techniques born, like A/B testing, blue-green deployment, zero downtime, all that stuff. More aggressive and fast automatic deploy techniques start to become very popular, and that's all the long story short. Next. Okay, a little note about difference between continuous delivery and continuous deployment. Nowadays, we have an increasing number of continuous deployment projects and also some continuous delivery projects. The main difference between them is that on delivery ones, we keep a manual process to trigger production deployment. You can see in the red square. Okay, Nani, go ahead.
My turn. Okay. Okay, we're talking about a bit modern workflow and infrastructure and so on. At this point, we are review what happened in legacy systems, right? Legacy systems and legacy environments. That right? Okay, let's see it. Okay, the first scenario is when we have not a CD or continuous deployment, right? In this case, sorry. In this case, we have an ops team that are responsible to promote software, right, to production environment. Right? Obviously, this is a big bottleneck and need more people in ops team to manage the process to deploy new releases to production, right? But it could be worse that if we don't have C, right? If we, let's remove that piece, that element. No, that user upload to the control system, to the software control system, then will be sent to the ops team, right? This is a bit more
hard.
On the start, a bit hard scenario. Thank you, Cesar. And finally, we are on the head. The head is where the developers push their code directly to production. This is a very good scenario for hackers because they can find a lot of issues, a lot of flaws, a lot of bugs, probably in production systems.
Yes, manually. We have to say that developers manually deploy code with no techniques, no automations, and that's a very bad scenario.
Right. Cesar, your turn.
Okay. Some reasons. Next. Why we bother about this? Okay, we bother because reaching our customers more frequently and faster is a competitive advantage. Software leaders shown everyone that these kind of techniques are extremely profitable. Instead, spend several months planning and develop software. Now we can change it in a matter of hours safely. More extreme continuous deployment techniques persuade that every commit hits production, triggering tens of deploys on a single day. Next. But how this becomes so popular? Nowadays, it's uncommon to find a company that is not using one of these tools to automate at least one software project. In fact, new jobs emerge around these tools like DevOps, software reliability engineers, DevOps, all that kind of stuff. The use of these tools is increasing year after year. So let's talk about the lingo. Next. What a pipeline is. In order to achieve tens of deployments every single day, we need to decrease human factor to its minimum. To do this, we need to execute several software in a specific sequence. This sequence calls pipeline. A pipeline is made of several steps that can use some programs, and usually it's named after their goal, like compile, software, testing, or maybe tagging, add a tag, you know. Okay, next, what a DevOps is. The struggle between the development and operations became so intense that we need to change our company culture to achieve our objectives quickly. And from this close collaboration, born a new being, the mighty DevOps, the one who will bring understanding between these two worlds, and its name is DevOps. These new partners end with shared responsibilities, which usually no one cares about. In the past scenario, when you have developers and operations, sometimes these two teams fight each other for who is the bug blame of. Okay, next. Now we add another word, is sec. What a DevSecOps is. The next obstacle in our way to faster deployment was security. In the same way that development and operations did it before, now security must change their mindset to become allies. Security usually is seen as a stopper in several projects, involves security from the beginning, increase development speed, and reduce the risks, leading us now to modern techniques like threat modeling. Next.
Okay, sorry. Yeah. That. After that, let's review some typical setups of infrastructures and workflow. There is some typical step when we build software, right? The building workflow it itself is like the picture we can see this slide, right? From code, commit, C, pipeline, CD, right? But it's not enough. Then we split each step and name them. We include all, we include all the development step, and also we added user and prediction step because they are implied in the software development. Now we put our names to software that could be used in each step, right? We can see that typical software component of software pieces are GitHub, Travis, Jenkins, Bitbucket, GitLab, and yes, FTP, because sometimes the developers of software processes are a bit all process software finally ends in an FTP server. But when we create the software, this scenario is not enough. We need more pieces. And the missing pieces are the deployment provider, of course. And also, as you can see in the right on the slide, you also have your own server and your different provider, right? This is the big picture. This is the photo that we use to explain each attack in different steps following this scenario, right? Cesar?
Okay. Now we are ready to deep dive into the burning hells of pipelines. Go next. We start in source code. If we look our treasure map, we are now on the left side of it, okay? Go for it. First of all, our first foe, the ID leaks, the integrated development environment leaks. Please don't leak details of your internal deployment to the internet. Some details can be clues to find security holes. When you are using an integrated development environment, usually these put some files on your project, and these files must be ignored. You can see there on this picture that you can access to the code styles and some cache files, product workspace files, and the compiler, the encodings, a lot of very interesting things to know how your company works internally, and is very risky. Okay, go to next. The bad role granularity. Okay, sometimes you have no choice to set up several roles, or maybe you can set permissions on files or brands. If this is the case, you are suffering bad role granularity. Some can delete your production code directly or using other techniques, and you never know who was. If you can control how your files are managed somewhere by error, or someone evil can delete all your work and also even change your source code history, and you never know that was happening. A little note there, this can be even worse because all this stuff can happen in the developer computer. We say later, well, we will see later more about this, but some kind of developers tend to keep the code only on their computer, and this is also a very risky thing. Okay, next. This is the dev machine as only source code server. As I say moments before, you must ask yourself all these questions. There is a cowboy coder in your team. Let's see that beautiful image, Danny.
Okay, sorry.
That's it. Have you, you have very tiny software in production only managed by one developer? You have a guru developer, you have the correct security at the workplace, and also are your developers bring your own device to your office. All these things lead us to this risky thing, and we must avoid it. We need to keep safe our source code, make backups, and keep the workplace safe. Also, it's a good practice that more than one person is aware of anything that is used in production. If you have this kind of cowboy coder that is very active and do a lot of things, when this person leaves your company, can be a very big problem, because they leave the know-how of all these things. Okay, let's go next.
Okay, that's another typical site where developers go when they have doubts is Stack Overflow. They sort of copy and paste the source code that people write on Stack Overflow, but we know that they did. That's the reason, because we can find news like this. The most copied pieces Java code on the Stack Overflow contains an error, but if the piece of the of code has a small Trojan, it was copied too. I think that the answer could be probably please don't copy and paste source code without analyze it, right? Okay, are libraries allowed? Developers very often are trusted and usually don't check open source library that they use. They don't check if library have vulnerabilities or Trojan, or if they have some CVE in the version that they are using. As you can see, okay, let me. Oh, sorry, entering into right. In this news, we can see that popular JavaScript library was infected with a malware that is still Bitcoin from wallet. Right? This kind of things happen, and we there. Secret and leaks. Sometimes people forgot that a Git repository shouldn't contain sensitive data. Sometimes by neglect, and other because they don't know that Git is not a backup system. They put sensitive data into them. In the slide, okay, let me pass. Yeah, in the slide picture, we can see real sensitive data on public GitHub repository. Then I invite you to use the GitHub search inbox, put this string or something similar, and you can find a lot of repositories with sensitive data. Be careful with that.
Very popular, this one.
Yeah, and very useful, right? Okay, now we move on the building step, right? The move right, following the global diagram on our wheel in the middle left in building step. Right. Now we are in control artifact repository. Okay, the first case in the building step that we'll cover is the artifact repository control, because we should control, we must control what a developer can publish to artifact repository. Otherwise, they can publish malicious artifacts. What happens if they publish a Trojanized artifact? What happens when production system deploy this artifact to production environment? Right. That will happen is that we will have a backdoor in our production system, and this always is not good business, right? Please check it. Okay, then the environment leak. It's very common in CI/CD system. It stores sensitive data, like production API keys, credential, even Amazon secret keys, and so on, in variables. Usually, this data will pass to C, as I told you, in environments variables. If these variables are not protected in your C system, someone with access to the C or CD system can print these variables. And of course, if they print these variables, they can read the content of the variable. It's very obvious, right? But all of CD systems have a solution to protect the variables that contain sensitive data. As you can see in these pictures, GitLab, for example, core or have a special kind of environment variable that they call as protected. And GitHub has this special environment variables that they call secrets. This type of variable are not shown in the CI/CD console, even if a user print their content and want to read their content. And then please, it's very easy, then use it. Okay, this is a very nice attack. Is a reverse shell in the pipeline. Although developers have a limited access to the C, right, to the C system, when I say limited access, I'm referring by using a role-based system. For example, they have a developer role, not an admin, to the C system. But if they can execute arbitrary binaries, for example, netcat is a very common binary that is the most of the Unix systems, they could create a reverse shell. If the C system doesn't control the access to the internet, a malicious developer could open a remote backdoor in your C system, right? Then let's see a small demo as a video. Okay, this is a fun picture. Okay, in this video, we'll put netcat to listen in the 1, 2, 3, 4 port, right? Waiting for connection, and then in Jenkins, very famous, right? We'll create an script console, right? Nothing is trained until now at the moment, but the thing that we're doing is to connect to our netcat service that just put listen, right? You can see we created a reverse shell, and in this case we use Metasploit to connect, and then at this moment we have a shell in the C system. In this case, is a Microsoft Windows, right? It's very easy this attack, but very powerful. Cesar.
Okay, let's talk about a little the GitHub actions, the evil GitHub actions. In fact, the code that you use in your GitHub actions, who is written by? Maybe they have evil objectives. We all know how a contributor on GitHub Action starts to send all environment variables to their botnet to harvest secrets. This vulnerability is known as code cove. Please use trusted popular actions and check the latest changes frequently. Also, it's very important that agents has a good firewall and don't access the internet if they are not meant to. Also, your pipeline has critical deploy information, and be aware of that kind of actions that you use and how they use this information. Danny said a moment ago that environment variables are very important because our secrets lie there, and it's a very important thing that I want to stop and a minute to talk about. Please protect your environments. Okay, next. Other thing that commonly we found on the CD systems is a mighty bot. Deliver software in a company is a very demanding task. We feel tempted by shortcuts, like do all CI actions by only one an almighty bot account. If someone has bot credentials for some automation task, he has access to everything, and that is so spooky. Use correct amount of service accounts to the task that require it. Keep in mind that the bot user can do what developer demands, because most continuous delivery systems use software to do their actions, and you can write any kind of software that you want there. So if the bot has all permissions, by extension, the developer has all permissions too. Okay, let's move to the next. That's the evil agent. Okay, if you can download and execute any program, you can use a continuous deployment agent to perform any evil action that you want. But we see, as we see in a moment ago, Danny opened a netcat, but in that case, the netcat is in their machine, but you can do the same from the pipeline. You can download a binary, a static link in your pipeline and execute it. So if file permissions are not correct, the pipeline also can infect with malware an agent and use this as a zombie on a botnet. So be aware of that. Okay. Let's see in this small video how this attack works. A moment, that's it. Now we will see how we can, from a pipeline with any problem, download and execute any software that we want. And we can do this because this Jenkins is with the default configurations of security and with no internet control access. That's the curl for the download.
We are downloaded map.
Yes, and map, that is a very useful software to look your surrounding and maybe a lot of steps. And that is running and looking all our network. That's it. Okay.
Yes.
So we know that that's the thing. How we learn from this: limit internet access in the pipeline, perform a correct hardening of the infrastructure, and fix the execution permissions. As we say, that Jenkins is on default settings. Okay, move next. Docker Hub leak, that's a very interesting one. Some useful Docker command can publish on Docker Hub easily, and you can send Docker image full of secrets to a public Docker Hub profile without even notice. If you are using your own computer, it's very common mistake, do a Docker publish and publish to the wrong place. So you must to ask yourself if you have your own container registry, if you check that your Docker files are correctly right, and your pipelines has permission and access to publish in a Docker Hub. It's also good practice, allow only some agents to publish image and check Docker layer contents. Also check the Docker file. And we have a notice, a new there. Misconfigured Docker registry could leak confidential data, lead to a full-scale compromise and interrupt the business operations. It happened, that thing that I said a moment before. A Docker publish and we have a very big problem. Okay, move next. Keep your API safe. Nowadays, it's common to have several APIs in your company, so usually some programs call to company API. Also, do not open all API to the internet, only those who need it. So ask yourself, do you use the API? Do you control the CI/CD network access? Some tips: disable access from unnecessary places with a firewall. We say several times. Do not install vulnerable plugins. We have the two security CVE there in the screen to see. Okay, more things. Source code ransomware. Have your own source control server is very convenient, but keep it safe, it's not so easy. Infect this kind of servers with ransomware or create a ransomware that use client permissions to wipe and cipher user repositories is already a used technique. Don't keep the details of this API on public code and keep a correct authentication and authorization methods for this kind of servers. More suitable to happen those that use their own machines and mix personal and professional configurations. Please don't do that. And also, if a ransomware exists, it's because it works. Check permissions, do backups. Another tip, another new about hackers doing this. Okay, move next. The fact Docker. An evil Docker layer can contain software and grow massively on deploy. This can prevent to your company, as example, to deploy security patch. Try to use only official images and keep a local image repository if you can. Sometimes a fact Docker appears as the result of bad coding, but can slow all your company delivery actions massively. Okay.
Okay, I love the picture, sorry.
Yes. Okay. The evil Docker twin, very easy to perform and very dangerous. Build an evil Docker container is very easy, and poison your cache also it is. Keep under control your Docker builds, and please use layer verification in your Docker files, that numbers that go just the right from Alpine, maybe. Okay. Push a new Docker image from your pipeline called Alpine is a simple test to check this. If you can, anyone on your organization can do a huge damage in your deploy systems because they have a complete layer to enjoy. Okay, move next. Okay, the greedy service consumer, these things we see happening sometimes. If you use an external service, be aware of the limits. Some API limit the amount of calls by IP. If your continuous integration or continuous deployment has only one public IP and you have a greedy user of one service, you can deplete the limits and let other services stack in your pipelines. Keep in mind things like GitHub. Big companies, a lot of person accessing GitHub, and then all the thing stop to work because you reach the limit. Okay, let's move next. The deployment step. Okay, well, now we see the map. We are not on the right side of the map. We are almost in production. Okay, room-free internet. Production secrets lay on CI/CD until they are deployed. So security concerns must be as important as production. We usually forgotten resource is internet access. Keep a correct firewall configurations to avoid secret exfiltrations or leaks. We say this a lot of times. Okay, a Trojan jar. Java rely on jar files to deploy most of the time. Tools to build a fat jar or manipulate it are broadly available and easy to use. The Java native interface also allowed the execution or arbitrary executables. Keep an eye on the Java jar supply chain, please. It's very, very, very easy and extremely hard to detect without correct tools like our own artifact repository. Okay, go ahead, Danny.
Oh. Now, okay, the zip bomb. Okay, zip bomb is an old-fashioned attack, but it can be very dangerous in our C system. It's very easy to create and explode them, right? In a brief, a zip bomb attack consists in a special created zip file that when a user tries to uncompress it, the zip bomb gets a huge amount of the space in your hard disk, almost infinite, until your hard disk is completely full. right? Also, bombs format could be easily detected, right, with a good hardening. But there is a new zip bomb variant that is very hard to detect. And in this case, we have a problem, right? Okay, the most interesting about zip bomb is that there is a lot of software that use zip as a package system, like Microsoft Word, Java with the jar files, with the Word files, Excels, a lot of. There is some application servers that deploy new applications that was packaged as a zip format, like Apache Tomcat that deploy WAR files automatically. The WAR files are zip format package file, as I just say that. Okay, the question is, what if we create a malicious zip bomb file, rename as a WAR file, and try to deploy this application in a server like Apache Tomcat? Right? What happened if we do that? Because it's very, very easy to do that. You control the CD or C workflow. This is a small video with a sample about that. Okay, before we played it, let's see what happens. We have split the terminal in 3 rows. The first one on the top is when hard disk free space before deploy the zip bomb. Right? The second one is referring to the free memory and swap memory. And third one, we can see the CPU usage. Right, now let's play video. Okay, no, yeah, okay. Now we copy the zip bomb to the Apache Tomcat directory. When Apache Tomcat detects the new file, they try to deploy it. Right, we copy the WAR file via SSH or via security copy. Then we can see how the amount of this that the zip bomb get the memory until in 1 hour more or less system breakdown, because the disk is full. If the disk is full, means that we also haven't free virtual memory for allocating new processes, even for that the root user can log in a console to stop the zip bomb, right? And even more, this attack was more 1 hour in this case, more or less. It's very, very difficult to detect it, right? It's a funny attack, funny if you are the attacker, of course, right? Okay. To prevent this kind of attack, you must perform accurate hardening of your system by limiting how much resources a process can get. It's very simple measure, but very effective, right?
Okay, the memory bomb. Not so known as the memory bomb, can be sneaky as a bad building process and kill your machines again and again. Keep in mind that swap is also affected and can take down your machine. What is a memory bomb? A memory bomb is very similar to a zip bomb, but attacks your memory, your active memory, your RAM, but also your swap, that is standard RAM in the end. Okay, what happens if you run a memory bomb in a continuous integration or continuous delivery system? What if the continuous integration is deployed as a multi-agent? Let's see a little diagram to see. Okay, that's the sequence of events. First, you put a memory bomb in your Jenkins file. Remember that Jenkins file is source code. You can put everything you want. So the Jenkins master sends the job to a Jenkins agent and runs the pipeline and the memory bomb. So the Jenkins agent breakdown. Jenkins master detected that the job was not finished and sent the same job to another Jenkins agent. And the same happened again. So go to step 2. Sorry. Okay, move forward. That's it. We have more agents. Now the demo. Let's play it and see what happened with the memory. We execute the pipeline. Okay, wait a minute. That's it. We will see the output. In that case, we have a executable file called bomb.sh. And in a few moments, our system will halt and will not finish. Even the machine breaks. That's it. We reach. Everything is frozen. Even the Jenkins itself froze, and you can survive this.
Chicken is completely frozen.
Yes, nothing to do here. You kill all the things. Wait a minute. No recover from this.
No recover.
We are trying to, but the system is unresponsive. In this moment, I'm trying to open a console or do anything, but I can't because I execute this attack on my own machine. And that's the thing.
Sorry.
No, it's okay. Let's continue. Just to know that a memory bomb is a less known but more effective, and even more effective in Docker, because Docker has different controls for memory and that kind of stuff. Today, powerful computers can die very fast with no clue that what pipeline is responsible for. It's very fast. As you can see, in a couple of seconds, it's unresponsive at all. You can lose all your agents before you find where the problem is. You have this kind of behavior that all your agents are dying very fast, one and then another one and then another one. Check this kind of scripts. Okay, let's move to the next one, bomb. And more traditional, the fork bomb is the all good fork bomb. When you open a lot of process and then your system breaks down. The all fork bomb still is a problem. Easy to execute from a prime line, can have similar effects than memory bomb, and it's more easy to detect if you have very, very good logs, but only in that case. Let's see what happened with the fork bomb. It's the behavior is almost the same. Okay, let's go to play it. That's it. With a very less criteria from my perspective, I execute this also on my machine and die very, very fast also. Okay, now it's downloaded the files from the JIT. And now execute, it say that it's success, but the system is also unresponsive. And down in the image, I don't know if you can see, but the number on orange on the left down, that is like 800 is our CPU usage on my machine, and it's completely gone. 1,000, 1,200, a lot of CPU usage, and then go down my machine also. Totally die. Very fast, as you can see, that's real time. In a matter of seconds, we have a responsive system. Okay, we can move next.
Yeah. Now on production, next step. Now we are focusing on the final step of the workflow, the productions. Is your API owners, right? New applications are built by using APIs. Most of our applications implement API to perform the most common tasks that usually day we use, for example, I don't know, Twitter, Facebook, and so on. But the new API is the fact standard, right? But you don't know, you have not a contract in the most of the cases but you don't know if your API's responses that you expect that they should respond, right? And that the question is, are you sure that your API responses don't add more fields that we defined in the contract? Are you sure that your API doesn't respond a different type of data that we define in the contract? Or are you sure that a malicious developer can use your API to exfiltrate data by using extra fields on your API? Did you check that your API are honest? Okay. The answer in this case is very complicated. You should check that your API contract are following. In this case, we propose the two tools. The first one, API Check, is an open source tool set for working with APIs. And the second one is a product for a vendor that have test cases to check these specific issues. It tests if your API are honest, right? We don't put more tool because we don't find it as open source or another provider, right? Right. Keep secret safe. Sometimes we forgot that Docker images are only a package software that could be opened by someone in their computer. As we don't put sensitive data into an artifact that will be privileged in a public repository, we must not put secret and sensitive data inside a container. This is obvious, right? But by using a simple grep command, we can find expression that contain password in a Docker images after we mount those images in my local machine. And we can find easily API keys, Amazon access keys, etc. Okay, this image. Okay, as you can see in this image in 2019, the cyber threat intelligence team were analyzed 1,000 of Docker images published on public repositories, not only Docker Hub, and they found a lot of secrets inside them. This is a real fault, and it's very common.
Daniel, sorry to interrupt you. We have about 1 or 2 minutes left. So if possible, please.
Please, okay. Well, directly to the last demo on the infrastructure, the evil alias. These attacks are fashion but useful, right? If someone with access to a machine could write a terminal alias, it doesn't matter the cell they are using, it could be anyone. The attack consists in replace a legitimate command with an alias that performs actions before run the real command, right? Okay, as you can see this image, some example about evil alias, right? With a demo is nice. In this case, this demonstration, we are use Netcat and listen to 1999 port. We create a new alias for the ls command. When a user type or execute an ls command, this alias will send all of the environment variables to our server. Yeah? Very easy and very powerful. All right. Now we load the new configuration and type ls. Right, and that's it. Very easy. We receive all of environment variables, and it could be secrets and so on. Right. Finally, these are infra. Okay, let me check if I have. Okay, I have no more demos. Right. It's very common to deploy the system and production system and share network. The only thing in this case is please use isolated network for C and see the environment, then your production system. All right. Okay. I'm sorry, but I have no time. Please, the conclusion, if you use VPC, VLANs, and something similar. That's it. The conclusion.
The wrap up is all this kind of stuff. We have no time to this. This is only the type of iceberg. Please be aware of all of this, and we can we can reach us in social media. Okay, next, Danny. And you can see our Twitter. We are very active on Twitter. Ask anything, any question that you have, please.
No.
All right,
that's it.
Thanks.